We want to find the area of the region between the graph of f(x) equal 1 over square root of 9 minus x squared and the x-axis on the closed interval from -3 to 3 if it exists. As we look at the graph here, we can see why we would have this if it exists question, because -3 and 3 are vertical asymptotes of this function. Does this area exist, or is it infinite? Let's go ahead and see what we can find out. So this area will equal the integral from -3 to 3 of 1 over the square root of 9 minus x squared dx. Now we have an improper integral because we know that here we have this infinite range. So let's go ahead and use a couple of things. Actually, as we see here, we have an even function, and so if we needed to pick a value here, and so we're going to pick 0, and because we have a symmetric integral over this even function, we can actually just do 1/2 of it. Otherwise, when we have these two, we would have to do both pieces, but one way we could do this is use the symmetry of this and say that we are going to have the limit as b approaches 3 from the left-hand side, and we'll just do this piece and then we will double it. So 2 times the integral of 0 to b, and then we have our 1 over square root of 9 minus x squared dx. So in looking at this, I see this and I say trig substitution. So I'm going to draw a triangle, and I'm going to label the hypotenuse 3, here's theta, and this is x, so that this side is the square root of 9 minus x squared. So connecting those simpler sides, sine of theta equals x over 3. So my substitution is x is going to be 3 sine theta, and my dx is going to be 3 cosine theta d theta. So doing this substitution now, actually, because I have this 0 to b and I don't want to think about trying to get this in terms of my new variable, I'm actually going to just go down here and compute this as an indefinite integral in theta and then resubstitute and then go ahead and do the evaluation. So what I'm interested in doing is integrating 1 over square root of 9 minus, I'm going to replace the x squared then with 9 sine squared theta, and then my dx is going to be 3 cosine theta d theta. So in simplifying that, I have the integral of, here I could factor the 9 out and have 1 minus sine squared theta, and that's underneath the square root. And when I replace this with the Pythagorean identity, this is going to be cosine squared, square root the 9 and the cosine squared, and get 3 cosine theta. Well, then that 3 cosine theta will cancel with this, so all as I have is the integral of d theta, which is just theta, and we don't need plus a constant because we're going to go back up here and do our definite integral. So as we go back up here, I still have the limit as b approaches 3 from the left-hand side of 2 times, this is just theta, but what is theta in terms of x? Well, we have this right here, and so theta would be the inverse sine of x over 3. So this is going to be sine inverse of x over 3 evaluated from 0 to b. Now as we look at this, then we'll go ahead and write that right down below. So we've got the limit as b approaches 3 from the left-hand side of 2 times sine inverse of b over 3 minus sine inverse of 0. So as we think about this, let's look at the second part here. We can see that when is the sine 0? That is when theta is 0, so that one's easy. Now looking at this part, we're letting b approach 3, as from the left-hand side, as b approaches 3, we would get 3 over 3, which is 1. So when is the sine 1? That is at pi over 2. And then we're also going to multiply by this 2, so we get pi. So we can answer this of it does exist, and this area under the curve from -3 to 3 is pi.